Great. Okay, now let's focus in on what is passive building and what does it really mean that a home is high performance. So that gets into how energy efficient they are, how resilient they are with weather extremes and mold resistance. They typically use eco-friendly materials. They have the highest levels of healthy indoor air quality and CO2 monitoring. They're usually very efficient with their water usage and water heating. And the main thing is they are just incredibly comfortable and quiet. Now, I spent most of my years living in Chicago, and if you talk to anyone here who's lived in a typical old Chicago brick home or apartment building, in the winter you can see the curtains blowing around from all the air leaking in from the windows and the poor walls. So that all goes away when you get into passive building. So just to give us some context, most energy efficient homes are rated in the HERS index, the Home Energy Rating System. And an existing home that might be, 50 to 100 years old might rated 150 on the meter here. And this is kind of like golf, the lower the score, the better. So a score of 100, which is kind of the baseline, comes from a new home built from the 2006 code standards. So EPA's Energy Star program seems to fall somewhere in the 70 to 80 range. Same with LEED. But now Passive House comes way down here to a score of 20, which is incredible. And then if you add solar panels or renewables to that, you can get to your net zero house here at zero, and you've really accomplished something incredible. And then what we're hoping to do in the future is take it even further and actually generate more power than our particular home needs, and we could feed the extra into the grid for other people to use, and get our planet off of burning fossil fuels or even using nuclear energy to provide its power needs. All right, so how does the theory of passive building do this? So if we make a graph of all the heat losses leaving our home, and we look on the left, we would add up first losses from ventilation and air leakage. We would be losing heat from our connection to the soil. Of course, we're losing heat as it wafts out of our poorly insulated envelope, all the walls and the roof. And then, of course, the weak link in our building are usually the windows, because they're the least insulated and most drafty. And so we could add it up, and on average, we're looking at this 120 kilowatt hours per meter squared. So now, what do we have to do to replenish all those losses? And the gains come in on the next graph. From our windows, we get free heat from the sun coming in, mainly the south, east, and west windows. We get internal heat gains from cooking, from body heat in appliances and electronics running. But that only gets us so far. So the rest of replenishing what has left the building envelope has to come from heating. And that's a lot. It really adds up. So the philosophy then in Passive House is, if we could really minimize what escapes from our building envelope, really shrink the ventilation and leakiness losses, if we super insulate the walls and the roof and the floor so hardly anything escapes from the shell, and use higher performing windows and doors so less escapes from those elements, we dramatically reduce our heat losses here on the graph shown by up to 73%. So this is great. What does that mean? That means if we take the same solar gains from our south, east, and west windows and the same internal heat sources as before, all we need to do now to make up for the remaining heat gains is quite small. And we see here it's a reduction of about 86%, which is incredible. So that is really the mantra of passive building. Make a super insulated, airtight shell so that hardly any energy can escape. And if hardly any energy escapes, then do we hardly have to run our furnaces to replenish what is lost. All right, so the first main principle in passive building is strategic design. So this starts with smart siting of the house on the property. So for example, the Lakeside Net Zero Passive House, it had wonderful views to the north and to the east. It was situated on a lake, and that's where all the day rooms really wanted to focus their views. But what makes designing this home to become net zero so challenging is that the good sun we want is all behind us. It's coming in from the south. So ideally, the views and the solar gain would be coming through the same windows, but for this particular project we were challenged and it didn't work out that way, and so we actually used the second floor to really add lots of south-facing glass to get that free heat from the sun and still maintain our lovely views to the north. Another part of strategic design is being conscious of the surface area to volume ratio. So if we maximize this ratio, we would probably end up with a spherical house, because a sphere is the shape that gives us the highest ratio of interior spatial volume to square footage of building envelope. If we go with a cube shape, which is also very favored in passive house design philosophy, we end up with a very favorable surface area to volume ratio. And this is unlike kind of passive solar designs from the 1960s and 70s, which was really focused on stretching the house in a long rectangle, thinking that if we stretch the surface area to the south, we could pick up a lot more solar gain. So we want to be very conscious about this ratio, and it helps to keep shrinking this volume. I like to use this Not So Big House book, which talks about how best to minimize square footage to keep things compact. So we want to lose rarely used spaces. We want to focus on spaces that are used every day with multiple purposes, doubling up on functions where possible. Now, the smaller the house, the less there is to heat and cool and clean and maintain, and it lowers construction costs and energy costs. So that's a win-win, win-win. Another part of strategic design is some of the tools that we use to analyze the site. So what you're looking at here is a solar pathfinder. We use this on both projects. You set it on the project site where you think the home is going to be located to analyze the effects of the existing trees on shading or limiting the amount of solar gain we're going to get through the windows. And as you can see, there's kind of a acrylic shell on the solar pathfinder, and it reflects a silhouette of the trees, and we can actually calculate how much solar energy we can anticipate on a certain face of the house. And we could also do some what ifs. So on the right side of the solar pathfinder, you could see the yellow dashed line. We said, well, what happens if we remove these couple of pine trees? You know, how much more solar gain are we going to get? And what if we remove this one deciduous tree that's kind of facing due south? You know, again, how much more solar gain do we get? And so this is a wonderful tool that helps us for strategic design. Another thing we've done in the past is we will model in the computer the heights and shapes of the various trees on the site. And we will place our house on the site and do a solar animation. And we will project during the summer months and the winter months what the shade looks like and what is the sunniest spot on the property to situate the home for maximum solar gain, not only for heating through the windows, but also where we want to mount the photovoltaic array to maximize our energy gain throughout the year. And what was nice about the Lakeside Net Zero Passive House project is that the couple of trees we had to remove for the home siting, we saved them, we brought them to a local mill. They were milled into boards used for the hardwood flooring, as well as building most of the cabinetry in the house. So a very eco-friendly approach.